Hello again. This is Eric Sackowitz, CTO of SecureCo, and today I'm going to show you our SecureCo Stratus mesh network transport. I'm going to give you some insight on how it operates from a visual perspective, which should give you a better idea of why it's so powerful. Now, this is leveraging our stealth and obfuscation tactics and levers that we apply. This is the fundamental architecture that is making up our secure transport. So let's get started. I'm going to create a network with 100 nodes with a certain number of gateways, which is our destination. And for now, we're going to leverage the major cloud providers, AWS, Google, and Azure, although we can extend to on-prem solutions or other providers as is needed by our customers. We're going to launch about 500 of our Connect clients, which are SecureCo enabled endpoints. They are the source of where information is from and going to the gateways that ultimately end up at an API endpoint or a secure data center or a VPC in the cloud. It really doesn't matter to us. So let's launch this network. And there it is, spinning up. And very quickly, you'll notice some activity. Down below is representing those 500 Connect clients that are connecting through this mesh, leveraging AWS, Google, and Azure, and ultimately going to the gateway. Now it's moving very quickly because this is in real time, but through the magic of programming, we can slow down the interface so that you can see what's actually happening as far as the data transport. So I'm going to bring it down to about 1% so that the screen can render this correctly. And as you notice, you will see as I zoom in here, the actual tails of all the traffic going through. And this is the power of obfuscation. The more nodes we launch, the more it is able for us to hide that data in transit and obfuscate it through lots of multiple pathways. Effectively, this creates what we call a moving target defense, which means it's very difficult for an adversary or an attacker to actually point to where both the data and transport originates, which protects the endpoint at the source beginning, all the way through to where its destination is. Now, this is based on the premise that the cyber kill chain starts with reconnaissance, and that reconnaissance happens largely in an area that nobody controls, which is the internet. And this is an overlay network that is actually providing you a secure transport through us without providing identification of what is the content, who is sending it, what's the metadata around that content. It is completely secured through our software-defined network. Now, let me drill it a little bit and show you things here, like what could somebody see if they hopped onto one of our Google nodes? Well, I got to tell you, they ain't going to see a lot. We split the signal across multiple locations, and it's constantly changing those pathways thanks to our rendezvous technology. We'll have another explainer on that, but a rendezvous basically means that every endpoint that is running SecureCo software, which in this case is the gateway in here, at the bottom are clients and throughout the network, that when a connection is established from the clients, they actually negotiate a random location on this mesh network in which to connect, which means that these endpoints specifically, as well as here, we do not allow or require ingress support. So on your firewall, deny all ingress, which is fabulous for network engineers because in this case, you're not fending off those who are doing nmaps or interrogation of your APIs or interrogation of what services are running on your servers, nor can they determine where and who and what it's coming from. This is extremely powerful. of a solution. And I'm not just saying that because I work here. It's because the architecture is extremely resilient and capable of doing lots of things. So as I was showing you, drilling in here, you're not going to see anything. And we always anticipate an adversary could take over a node. And we're fine with that. You go, Eric, why are you fine with that? Because there's nothing for them to learn on that node. Certainly, they can't get through our, multiple levels of encryption, which in this circuitry, every single client, and this is configurable, takes multiple hops through this network before it gets to its origination, right? And constantly moving those hops through our rendezvous technology. So it's always moving. It's always changing its circuitry so that it doesn't give adversaries time on site to analyze this. And also means that every one of those hops are actually encrypted with another layer of encryption. So if it's taking 6 hops through, it's actually effectively getting 6 layers of encryption, plus an additional layer we add on there, which is TLS, plus, of course, the actual security profile of your own application. So if you're using TLS or you're using government level encryption, that posture remains the same. We don't alter it. We don't man in the middle it. We don't store it. It remains intact. So we're just adding layers on top of that in addition to this obfuscation methodology. So that is another good point here. So the most anybody could do on one of these nodes, other than not being able to understand what all this gobbledygook is, hey, shut it down. So let me just speed up into real time, or else it just won't be as exciting to see because it'll be moving slow. So we're back to real time. And I go to one of these nodes and I say fail. And if I can zoom out really quickly, it's probably happening so quickly. All of these clients and circuitry just reconnected. We just don't care. We will persist whether or not a particular network provider goes down or whether or not a node goes down. So persistence of the transport is important. Redundancy is important. There are no central points of failure. In our tunnels, we don't have concentrators. We don't have devices that have to sit on this end. All of these clients can connect and all these servers can connect through any number of nodes here, right? So you have total redundancy of the entry and exit points. Again, redundant and fault tolerant for persistence. Now, is it ever happened where, I hate to pick out any one provider, but AWS East goes down, or God forbid AWS totally goes down? It can happen, no matter how great they are. What happens in that scenario? Well, let's go ahead and do that. Let us kill AWS. Right away, our algorithm will rebalance. This has a lot to do with the fact that we are just always refreshing our circuitry anyway, but we detect an anomaly and we reconnect. Now, what's also very important, because this question comes up a lot, is what about the latency? All right, what is the latency? All these mechanisms, Eric, they're great, but if it slows us down, we've got problems. Well, good news there. We have optimized this across the last 8 years of developing this software to reduce and keep latency low. You saw it was 14 milliseconds before, 19. We are very low latency. Our low bar is video, live video. Actually, the origination of a lot of this technology came from live video around the world. And defending against nation-state attacks, that it actually originated as being the purpose-built reason for this. So latency is not a concern. The moment you hit our edge network, we're accelerating across the terabit backplane of all of these cloud providers. So it's accelerating basically from point A to where it exits, wherever that might be. Now that can get complicated as we start to regionalize and we start to go across the pond, but we have not seen any significant degradation. Plus, I think it's important to know that we can run in as low as a sub 128 kilobit environment. So that is optimized for things like satellite-based communications or things that are done not through non-traditional high-speed broadband or high-speed wireless. So it's extremely resilient and very fault tolerant, and extremely configurable. All of these different capabilities, whether it be how many hops through the network, how frequently the circuitry change, the moving target defense, are all business rules that are done through our portal and based on us working with the customer on what is their risk tolerance, what is most important to them. So I hope you enjoyed this little view into Stratus. Thanks and have a great day.